Hello everyone and welcome to the third video of the MECH 220 video series. Today we'll be doing a kinetics problem with rectangular coordinates, and I especially like this problem because it combines stuff you've learned in statics in MECH 210 and the first video we did with the relative motion of the cable. So let's get started. So the question reads, if the motor draws in the cable with an acceleration of 3 meters per second square, determine the reactions at support A and B. So we want the reaction forces, right? So, and we were told that the beam has a uniform mass of 30 kilograms per meter, and that the crate has a mass of 200 kilograms. And we're told to neglect the mass of the motor and the pulleys. So with any kinetics problem, a good place to start is with doing the free body diagrams. So here, I would say it's most convenient to do a free body diagram for the crate and the beam. So let's start by looking at the beam, and that's going to help us decide what we need. So free body diagram of the beam. So we have a pin support at A, and that's going to mean we have an AX and a AY. We're going to have a tension from the rope there, and another tension, and we have a roller support BY, and we have the mass of the beam. So right in the middle we're gonna have mass of the beam G, and let's give this an XY coordinate system. Alright, so we need to find AX, AY, BY. We know that the mass of the beam is going to be 30 kilograms times the 6 meters, and we don't know what the tensions are. So to get the tensions, I think we would get them from getting the free body diagram of the crate. So I'll just make it clear that we don't know what T equals. We don't know AX. And BY, right? So let's do the crate now. So the crate has a tension, right? The rope gives it a 2T tension. I just find it's more clear if I put the pulley in as well. And you have the mass of the crate times the gravity. So if we do the sum of forces in the y direction for the crate, it's gonna, since the crate is moving, this is a kinetics problem, it's not static. For the beam, it's gonna be equal to 0, the forces, but here it's gonna be equal to MAY, which is going to give us 2T minus MCG is equal to MAY. And this is again mass of the crate. We know MCG is going to just be 200 times 9.81, and this is 200 as well. So we don't know what T is here, and we don't know what AY is here. Alright, so these are our knowns now. So how can we get either T or AY? So this is where our cable analysis comes in. We could get AY because we already know that the motor draws in the cable at 3 meters per second square, right? And just by looking at the pulley, we could say, oh, the pulley is going to divide the acceleration in half, right, for the crate. But just to be sure, let's see if we get the same answer by doing our analysis. So let's do our cable. So let's say this is our datum here, right? So this we'll call SC, and here I'll call this SP. So then we know that we need to get the length of the cable now, right? The length of the cable is just going to be SC plus SC minus SP. And if we rewrite that, we just get 2SC minus SP. And now I want to derive this twice to get the acceleration, right? So derivative of L is just 0 since it's a constant. And this is going to give me 2AC minus AP. And I'm told that the acceleration of the motor draws in the cable at 3 meters per second square, right? So that will just be the same as AP. So therefore I can get that 2AC is equal to 3, which gives me AC is equal to 1.5 meters per second square. So now that I have AC, which is the same as AY by the way, I'll write that down, AY, I know I can go back to my free body diagram of the crate and get the tension, right? So I'll just number it so it's more clear. 1, then we did this. So I'm gonna come back and get the tension here. And this is gonna, plugging in, it's going to give me T is equal to 1131 newtons. Alright. Now that I have the tension, I can go back to my beam, and now it's just a statics problem. I have all the unknowns. So I have 3 unknowns here, and I know my statics. I have 3 equations. The sum of forces in the x is equal to 0, sum of forces in the y is equal to 0, and the sum of moments is equal to 0. So now I'm going to do the sum of moments about A, and it's the most logical place to pick because AX and AY both go through point A, so I can get BY from this since I know what T and the force of gravity on the beam is. So I'm going to get minus T times 2.5 minus T times 3 minus MBG times 3 plus by times 6 is equal to 0. And keep in mind, MBG here is 30 kilograms times 6 meters, right? Times 9.81 meters per second square. And then we multiplied by 3. And that's going to give me By is equal to 1919.65 kilonewtons, not kilonewtons. Alright, and then we could do sum of forces in the y is equal to 0, and that's going to give me AY minus 2T minus MBG plus BY is equal to 0. Solving for AY, we get AY is equal to 2108.15 newtons. And doing sum of forces in the x is equal to 0, we get AX is equal to 0. Alright, so here's our answer. We have BY, we have AY, and we have AX.